Let us have a quick review on IMF. Stands for intermolecular force of attraction, right? So we will talk about the attraction between covalent compounds under IMF, okay? But we have attraction between ionic compound as well as when it is dissolved in water or any polar solvent. So that we call it as ion dipole attraction. Okay, we will explain that one. So under covalent compounds, we can actually classify that one into two again. That is in polar compounds and non-polar compounds. Okay, so again for polar compounds, I can talk about two. So that means dipole-dipole. It's a special case of dipole-dipole which is called hydrogen bonding. Okay, and in non-polar, we call that one as London dispersion forces or simply dispersion force or just LDF. Okay, so let's go ahead and explain what is dipole-dipole very quick. So to decide whether it is polar or non-polar, look for electronegativity difference, and sometimes you may have to look the shape as well. Just draw the Lewis dot and look at the shape. And for the electronegativity difference, say for example, if you have HCl, HBr, you can see that Cl has higher electronegativity than hydrogen. Br will have higher electronegativity than hydrogen. So the shared pair of electron will move towards bromide ion, and it will have a slight negative charge, and hydrogen will have slight positive charge. Likewise here as well, chlorine will have slight negative, hydrogen will have slight positive. And in the case of water, if you are taking, oxygen will have slight negative because oxygen is more electronegative than hydrogen. So electron will pull towards oxygen and hydrogen will have slight positive. So you can, in all these cases, you can see positive and negative side. That means two poles, positive and negative poles. So when these molecules come closer, say for example, HCl is coming closer to another HCl molecule, we will have what? A small attraction between the particles. So we will have Cl attracted to hydrogen ion and Cl minus. It can continue like that, correct? So that is what is called dipole-dipole attraction. So whenever there is electronegativity difference and there will be polarity, and go for the dipole-dipole. And now another example, these are simple molecules. What if we have CH3Cl? How will you decide? Draw the molecule. The Lewis dot for that one, the tetrahedral. So you can draw H, and Cl. Cl will have more electronegativity, so electron will be pulled towards it, so it will be negative, it will be positive. So it can create dipole-dipole attraction. And for hydrogen bonding, it's a special type of dipole-dipole, but in that case, in the polar molecule, there should be hydrogen, which is bonded to either fluorine, oxygen, or nitrogen, 4 elements. So for example, let us take the water molecule. We just explained it can have dipole-dipole, but it can be a special type which is called hydrogen bond, because the hydrogen here is attached to the oxygen. So this hydrogen can form a attraction with a neighboring water molecule like this. So we call this special type of dipole-dipole attraction, we call that one as hydrogen bonding. So you can have hydrogen bonding in ammonia because nitrogen is bonded to hydrogen, and nitrogen will have a lone pair, it will be polar, and it can form hydrogen bonding as well. Nitrogen can form bond with a neighboring hydrogen, correct? So this nitrogen will have hydrogen, hydrogen, hydrogen attached to it. So you can see that this hydrogen is sandwiched between nitrogen and nitrogen. This hydrogen is sandwiched between oxygen and oxygen. So that is called hydrogen bonding. And now in LDF, how can you decide which one will form LDF is, if it is a non-polar molecule, say for example CH4, It is non-polar. You know that all sides equal. Not like the one we just explained, CH3Cl. In all these sides, so what will happen here because of the shape, the dipole moment cancels and it will not have polarity. So this is going to be non-polar. So we will say it will have only LDF. And also we can say in argon, or if I say in krypton, what type of attraction? In iodine, in bromine. There is no electronegativity difference between bromine and bromine. So it is going to be non-polar. So the IMF is going to be LDF. Okay, that's how you are deciding which one will have what type of IMF. And for the ion dipole, what happens is when you dissolve sodium chloride in water, we already know now water has dipole, and sodium chloride also is polar because sodium is positively charged and chloride ion will have negative charge. So what happens when you dissolve that one in water? What happens is that oxygen is negatively charged will surrounded with a positively charged sodium ion. So we can draw like this, and on all sides we can draw that. You see that we will get the attraction which we call ion dipole because water got dipole and we have ions here. So that is why the ionic compound is involved in this one. So that is called ion dipole interaction. Okay, that's a very quick review how to decide which molecule has what type of IMF.